Lesson 1.7, absolute value. Remember, the absolute value is the distance from 0. So negative 4 is 4 spaces from 0. So the absolute value of negative 4 is 4. The absolute value of 10 is 10. And then with the negative outside, we do the absolute value of 8 is 8. And then this is read the opposite of the absolute value of 8. So it'd be the opposite of 8. To solve each of these, we just want to kind of reason out what numbers will and won't work. We want x plus 2 to equal 3, so one value for x would be 1, because 1 plus 2 equals 3. And if we took the absolute value, it would equal 3. But now if we think, we could also have a negative 3 in here and have the absolute value equal 3. So if we think, what would make that a negative 3? And we get negative 5 plus 2. That would be a negative 3. And when we took the absolute value, we get positive 3 again. So we have two solutions, 1 or negative 5. Those are our two solutions. Now let's take that to this. We want x plus 2 to be smaller than, less than or equal to negative 3. So we know that 1 and negative 5 is where it's equal. So let's think about 0 for just a minute. 0 plus 2. That's going to be 2, which is less than 3. And if we think about negative 3, see, I'm picking numbers in between 1 and negative 5. So there's 1, there's negative 5. If I pick like 0, then that makes it true. If I pick negative 4, negative 4 and 2 is negative 2, and that's less than 3. Now what if I pick negative 6? Well, negative 6 plus 2 is negative 4. But when I take the absolute value, then it's positive 4, and it's no longer less than 3. So I would be in between these two numbers. So in this case, my x would be in between the negative 5 and the 1. Now on this one, I want it to be greater than the 3. So we already looked at the 6, and we saw that when we put that in, it made this greater, because negative 6, that'd be a negative 4. The absolute value is 4, is greater than 3. If I tried a 2, that's 2 plus 2 is 4, that's greater than 3. So taking that same number line we had before, numbers bigger than 1 and numbers smaller than 5 will make it work. So we would have x is smaller than negative 5, x is smaller than negative 5, or x is greater than 1. And since these are or equal to, so we'd have the or equal to. So that was just kind of reasoning it through. So there are rules about doing this, but it helps if you can think about it a little bit. Okay. So we saw when we solved an equation, we got two answers. So the way you get those two answers is you realize that this in here could be either positive 15 and it would make it work, or it could be negative 15 and the absolute value would still be 15. So we solve two equations. 6x minus 3 equals negative 15, or 6x minus 3 equals positive 15. We solve these two equations and that will give us our two answers. So we add 3 to both sides, divide by 6, add 3 to both sides, divide by 6, and we get x equaling negative 2 or x equaling 3. Another example, this says the absolute value of something equals negative 3. Now think about that. Can the absolute value of anything equal a negative number? So it can't, because the absolute value, when you take an absolute value, is always positive, so this would be no solution. Okay, now the last example here. Okay, now we have a little bit of a dilemma because we have an x outside the parentheses, so this makes it a little different. We're still going to do two equations. 2x plus 12 equals negative 4x. 2x plus 12 equals positive 4x. And that would be separated with the word or. Okay. So we solve this one. We need to get all of our x's together. So I'm going to add 4x to both sides of the equation and subtract 12. And I get x equals negative 2. Okay, on this one, I'm going to subtract the 2x, so I have 12 equals 2x. Let's see if I can get that a little closer so you can see that a little better. Okay, and then 6 equals x. The problem here is with that variable on the outside, there's a chance that we may have come up with answers that do not work. So we need to double check that our answers work. So we're going to come back up here, and we're going to plug in the negative 2. So negative 2 times 2 is negative 4 plus 12 is 8. And then over here we're going to plug in the negative 2. We get negative 8. The absolute value of 8 equals negative 8. That's false. So what we have come up with is an extraneous solution. So we can't use that one. So now let's try the other one. 2 times 6 is 12 plus 12 is 24. 4 times 6 is 24. The absolute value of 24 is 24, so that one's true. So our solution is x equals 6. So you need to check for extraneous roots or extraneous solutions when you have the variable outside as well as inside. Okay, now absolute value less than, we noticed on that example we did earlier that the answer was between two numbers. So the simple way of doing this is to realize that this is the value here has to be in between negative 8 and positive 8. So I'm going to go negative 8 is less than or equal to 3x minus 4 is less than or equal to 8. And then my answers will all be less than or equal to 8 when I take their absolute value. So then I can just solve this, add 4, divide by 3, divide by 3. So my answer, x is in between negative 4/3 and positive 4. And I could graph that. Okay. So another absolute value less than problem. So once again, absolute value less than 32, so this answer in here has to be in between negative 32 and positive 32. Okay, so subtract 8, divide by negative 3. Now remember, when you divide by a negative, you have to switch the inequalities the other direction. So this would be negative 40/3, negative over negative, which would be positive 40/3, r, and this would be negative 8. So my graph would be negative 8, positive 40/3, and it's nor equal to, so colored in circles and in between. And I could rewrite that with the smaller number, first. Negative 8 is less than or equal to r is less than or equal to 40/3, which would be 13 1/3. Okay, another less than. But now I have something over here with the absolute value. So you always have to isolate the absolute value first. So I'm going to subtract 14 on both sides of the inequality. So now I have the absolute value of 3r plus 6. It's less than or equal to negative 11. But now I need to stop and think about that. Absolute value will always be a positive number. And then less than or equal to negative 11, there's no way a positive number can be less than a negative, so there's no solution. So you always want to think about what you're doing. Okay, greater thans. With a greater than, it's an or. So the first thing we're going to do, you noticed on that first example that we had the split answer, and a split answer is always an or. The first thing we have to do is isolate the absolute value. So we have to get this by itself. So we're going to start by subtracting 10. Now that I've done that, I need to set up my or problem. It's going to create two problems. So I'm going to take the part inside here, 5r plus 8, and then it's going to be, remember it was split two different directions, so that's going to be less than or equal to negative 20. So see how I took this and I changed both of these. I less than or equal to negative 20 or, and then just copy this the way it is. 5r plus 8 is greater than or equal to positive 20. And that's how we get our split problem. So then we can subtract 8, divide by 5, we can subtract 8 and divide by 5, and we get r is less than negative 5 and 3/5, or r is greater than 2 and 2/5 on the number line. It would look like this. Okay, so now we have another problem. Now it looks like it's a greater than, but we need to make sure, well, here it says it is, so we know it's going to work out that way, but in the book it wouldn't tell you what kind it was. You have to figure that out. So the first thing I want to do is isolate the inequality. Isolate the absolute value. So I'm going to subtract the 30 from both sides. So now I have negative 20 is greater than or equal to negative absolute value 7 minus 5x. Well, I still have to isolate that absolute value. I need to divide by that negative 1. But when you divide by that negative 1, it switches the inequality. So it's 20 is less than or equal to absolute value of 7 minus 5x. Now at this point in time you might be thinking, oh well, this is a less than. But when we decide whether it's a less than or a greater than, we must have the absolute value portion written first. So you have to write the absolute value portion first, and then it's open to the absolute value side, and then the 20. So now we can see it is an absolute value greater than a number. So this will become a split problem. We'll have two problems here. We're going to separate that into 7 minus 5x is less than or equal to negative 20, or 7 minus 5x is greater than or equal to positive 20. So then I can subtract 7. And then I can divide by negative 5, which will again switch that inequality one more time. So it's going to be x is greater than or equal to 5 and 2/5. Then this one I'm going to subtract the 7. Then I'm going to divide by the negative 5, which will switch the inequality. So it's going to be x is less than or equal to negative 2 and 3/5. Okay, so that's hard for you to see. So I'll rewrite it over here. So we get our x is greater than or equal to 5 and 2/5, or x is less than or equal to negative 2 and 3/5. So I'm looking at that and it's kind of backwards. If I look at it on the number line, the negative 2 and 3/5 is here, and the 5 and 2/5 is over here. So it'd be better really to write that as x is less than or equal to negative 2 and 3/5, or x is greater than or equal to 5 and 2/5 to write my final answer. Okay, one more here. Subtract 25, isolating the absolute value. 3x plus 8 is greater than negative 19. Now we need to stop and think about this. Absolute value of anything is a positive number, and now it wants it to be greater than negative 19, so any positive will be greater than a negative, so the answer is that we can put anything in for x. So this is all real numbers. This is just an outline of the special cases, and here's a couple examples for you to try.